all kinds of weird stuff happening on Binance Smart Chain. I won't get into that this slide, but in our internal meetings, we're finding like tokens that appear in someone's wallet, and we have no idea how it gets there. Like we looked at it on the Binance Explorer. Yeah, all kinds of interesting stuff. So after this summary, I'm going to get more visual and show some diagrams. I feel like that's how things usually go. So this is the blue circles serve the wallet featureization block here. So on the bottom left is the Binance Smart Chain. That's how I think about it visually, right? We get blocks in sequence every 3 seconds, and it's accumulated into this cylinder called transaction database. So when we want to featureize at the wallet level, we run this main node, and it starts up a lot of workers who then goes to the transaction database, fetch a bunch of transactions per address, and build an intermediate database that is this wallet project pair. All of this is what we traditionally think of as ETL, standing for extract, transform, load. It's quite common in all kinds of data applications. And yeah, we have really good data engineering expertise on the team. So we can continue to do this for Ethereum. We can build low latency node listeners for these individual chains. So yeah, getting this part right is super important, and we continue to work on that. Now, for data scientists and machine learning researchers, that's the right part. So these green circles are in this, what's called a controller view model framework. So what a data scientist would do is take that cylinder from the blockchain featureization step and instantiate a controller. She would configure this controller with what's called a YAML file, and the controller in sequence would instantiate a loader for loading the data in batches, a model to predict something about the incoming data, and a view object which output the results and help the practitioner to diagnose what's going on. So yeah, okay, so the nice part about the right side that we have is if you have different ideas about what the model should be and how it should be configured, multiple data scientists can explore different models on their own while having the same controller, loader, and view. So this lets us explore more hypotheses about what's working or what could work. And likewise for the loader, if we want to process the data differently, different scientists can parallelize that process as well. That's kind of the whole point of why we have this layout for inference and visualization. Okay, so with that, and here are some low-level tasks we've been doing in the past 2 weeks. So the kind of issues we look at are like missing wallets in our database. We find wallets with like really abnormal behavior, like it could send out tokens without receiving any. We like check that with the Binance Explorer. And in fact, that is what's happening. So quite a lot of mysteries. And to handle that, if you look at this 3 to 4 audited wallets item, essentially what we're doing is hand audit the weird wallets, hand audit how we're computing these features. So it's been quite an adventure. And then on the inference side, so I've color coded it green corresponding to the inference on the right-hand side here. We've established this basic framework. We've been experimenting a lot with all kinds of machine learning techniques. And I want to present some early inference performance, but with the caveat that I think it's good, but it will be better. So, I'm excited. Okay, now we're getting into the analytics of what's happening on BSC. On the left is a distribution of different wallets holding times in number of days. So what's jarring to me on the left is within 1 day, that's how long like most people hold things for, is 1 day. That, or it's bots who are doing some pretty particular trading. Yeah, it's interesting. Most people want to test something out, like a DeFi contract, or just hold some tokens for 1 day for some specific reason, and then leave that position by transferring it out of their wallets. So if we look at, all the wallets that hold past 1 day, you get something like what's on the right. So we see like a steep drop off after 25 days. That's the first red dotted line that's been plotted. So, we're not exactly Vanguard valued clients, right? Like 100 days is a lot for us. So if you can make it past 25 days, that's pretty good already. So we call this class, this 25 to 100 day class, medium-term investors. And then if you leave your position before 25 days, you're a short-term investor. And then if you go past 100 days, you're a hodler, which is pretty good because the Binance Smart Chain is younger than Ethereum. It's been around for, I think, 2 years at this point. But really, the projects on Binance are, even shorter lived. They're even younger than 2 years. So that's kind of the task we are left with. We want to find who's on the tail of the right distribution. Who are the hodlers that will hold this project past 100 days? And sorry, there are some people there are some extreme outliers who can go past 250 days to 300 days. We really can't see them on this plot, but the fact that the plot extends that far means these entries exist. So just another comment there. And one more thing I think is, if you have multiple wallets, we would like to link those wallets to the same person. And also, if you're staking some tokens, we think of that as holding. It's holding the token still. So there are all kinds of nuanced questions to ask about who is holding and who's not. Okay, great. So metrics. Let's talk about how our neural network is doing. And first, how do we talk about it even? So if a classifier is often correct when it says it's a hodler, that means this model has high precision. Okay. But a different question is, if you have 100 hodlers in the population, can this classifier find all 100 of them? If it can find a huge percentage, it has high recall. So an implication is, if you have an optimistic classifier, it will try to guess hodlers when they're not. But because it's so optimistic, it will catch more hodlers by guessing them so frequently. Okay, so an optimistic classifier has high recall but low precision. So, right, inversely, if you have a pessimistic predictor, it will say, we rarely find hollers. You're not a holler. We don't care about you. In that case, the pessimistic model has high precision but low recall. So there's quite a bit of trade-off depending on how conservative your model is when it classifies things. So coming back to this distribution of holding times, hollers are quite rare. If we think about the mass under each partition of this distribution, right, hollers are more rare to find than the other two classes. In fact, about like 60% of all wallets are these short-term, exhibit this short-term behavior. Okay, so yeah, let's keep going. Okay, so this is how I think about what metrics to care about. If this Launchpad is working with a client project with a large budget, the goal of that project is to find as many hollers as possible while accepting a portion of what we think are hollers will dump this token, earlier than we thought. So before 100 days. And coming back to recall versus precision, we are looking at an optimistic classifier that can get us all the hollers. That's more important than mislabeling hollers when they're like short-term investors. So what does this mean? The neural network we tried can identify as much as 90% of the hollers in the test set. So I think that's pretty good. I think it comes at a cost though, because that means this is an optimistic neural network who like to give the benefit of a doubt to the medium and short-term investors. So we can identify the majority of hollers while accepting a large portion of these predicted hollers will actually leave this project earlier than we thought. So we have a clear path to identify the hollers while being precise about it, while having a high precision about it. That's the performance goal for the next leg of our work in this application. Yeah, and to keep things short and sweet, we're looking at more functionalities to build into this application. Like what I was saying earlier, if you have multiple wallets, we want to associate that to the same investor. Amit, another great data scientist on our team, right, said, hey, if we have two similar wallets, can we infer the behavior of one, the holding time of one, with another, because they behaved so similarly in the past? We can sort of graft information from between similar investors. And likewise, right, if you love holding gaming projects and we have a gaming project at the Launchpad, we want to explore project level similarity and use that information to granularize our prediction for your holding time specific to this project type. And then, yeah, there's more stuff. We can, instead of collapsing all the transactions of this wallet into one row that we saw in that CSV, we can input all the transactions of that wallet